Hey everybody, good morning. This is Mr. Ainsworth, and we're going to get into another lesson in section 3 here, and we're going to focus in on how money's compounded and the different ways that it's compounded. In our previous examples, we've developed some models to solve some problems involving geometric sequences, ones that involve a constant rate of growth or decay. Let's highlight that because that's an important part about what we've been talking about. In our financial example that we talked about, which involved annual compounding, we derived the following formula. So let's put it up here. Okay, so P sub n, our future amount, was equal to our initial amount, the seed, times some growth rate, or the second example dealt with a decay rate, so I call that R, raised to some power n, where typically in the previous examples that dealt with annual compounding, well, n was stood for the number of years. Okay, well, we can interpret these things in different ways, as you're going to find out. So what we're going to do in this lesson here is we're going to figure out or discover or learn the different ways to compound money and what's better than others. What we need to understand first, though, is that P sub n stands for some future amount. Okay, it doesn't always have to be money. In our second example, we talked about the gamma virus. Okay, and we predicted, the number of people afflicted by that. Okay, so, but in any case, whether it's money or people or whatever, P sub n stands for future amount. AMT stands for future amount. P sub 0 is the initial amount, okay, which we call the seed. In financial examples, it's called the principal, guys. Okay, principal. Okay, don't write it as PAL. Okay, that's the principal of the school. I'm talking about the principal amount that you put in the bank. Okay, so when you go deposit 100 bucks in the bank, okay, it's called the principal. Let's see, and R is the growth rate, or was the growth rate. Okay, it also could be the decay rate, so it depends on the problem that you're working with. Okay, and N stands for the number of time periods. Number of time periods. In the two problems that we dealt with, we're talking about number of years, but the time periods could be number of months, number of years, number of days, depending on the problem. So I want to say number of time periods. It's very important because that's going to change from problem to problem, as you're going to find out. Okay, because we're not always talking about per year. It could be per month, per day, per second. It could be time periods, or the transitions could be different. All right, now what I want to focus on right now is problems or situations that involve annual interest rates with money. Okay, with money. And so I'm going to be a little bit more specific here because we're going to focus in on money examples. So on this one right here, I'm going to write it as, and I'm going to put this one in red because we're going to use it here today, as the future amount P sub n is equal to the initial amount P sub 0 times 1 plus I raised to some power. Okay, where P sub n is, again, the future amount. Okay, P sub 0 is still the seed, or the initial amount. Okay, I stands for the interest rate. I for interest rate, right? That kind of makes sense. So interest rate as a decimal. Okay, as a decimal. That's important, so make sure you write that down. If you substitute in the percentage as just as straight percentage, you're not going to get the right answer. So make sure you convert it to a decimal. R represents, well, it's the overall rate. Like in the first equation here, this right here is equal to 1 plus I. You can see what I'm talking about right here and here. R is 1 plus I. So that's the new part. So 1 plus I. It's kind of like taking 100% plus the interest rate. So 1 stands for 100% actually, because 100% is 1. Just think about it. And then the letter N here, the variable N, stands for the number of time periods again. So number of time periods. Okay. Okay. It could be years, could be months, it could be days, it could be anything. You have to read the problem and interpret it. Okay, so let's interpret. Let's go for it. Get your calculator out because you're going to need it. Okay, put your phones away. Use your calculators and use them well, because we use what we test with, and we test with calculators and not phones. All right. So be responsible and put your phone away. Here we go. Suppose that The you invest 10,000 into an account. There's your seed right there, your initial amount. So $10,000. All right, it pays an annual interest rate of 7.5%. Okay, there is I, so 7.5%. That's 0.075. Okay, if you don't know that, take 7.5 and divide by 100 and you get 0.075. Use your calculator. Okay, so you put it in an account and let it grow. Okay, how much money will be there at the end of 10 years? Okay, 10 years. So, first of all, R is equal to 1 plus I. All right, so it's 1 plus point, let me spell that right there. There we go, 1 plus 0.075. So R is 1.075. N is equal to 10 years in this case. Okay, so now we're ready to start the problem. Let's find the amount after 10 years. We'll call that piece of 10, where N stands for 10, right? Right there, 10 years. And that's going to be equal to our initial amount, $10,000, times, all right, our growth factor, which is 100% plus 7.5%, which is 107.5%, which is equal to 1.075. That's, whoops, that's where I get this number here. That's why we add 1 to the decimal, because it's the same thing as adding the 100% to our percentage like we did previously. It's just quick and easy to write it 1 plus I, where 1 stands for 100%. Okay, and then raise it to 10 years, all right? And let's figure this out. Like I said, these are calculator problems. So on your scientifics, probably what's going to be easier is if you start off with the base here, 1.075. You have to raise it to the 10th power. So you find your exponent button, which is right here, or your y to the x button. So raise it to the 10th power. Hit the equal button. Okay, and you get a number. And you multiply by 10,000, which means you shift the decimal 4 places right. So times 10,000. Let's make sure I put the right number of zeros in there. 10,000. Hit the equal button, and you get 20,610. So 20,610, and how many cents? Let's see here. Got to round it, right? 32 cents. See the 5? And look at the third digit and round the second. So 32 cents. So 32 cents. That's what you have after 10 years, my friends. Okay? That's all there is to it. All right, now if you want to have a little fun with this, you're going to pause and play through the lesson here. So if you guys think you got it, and you can pause the video, pause it and try number 4, and then press play and check it. Okay, if you're not sure, okay, you can let the video run. But if you want to challenge yourself, go ahead and pause the video and then play when you're ready. All right, so I'm going to assume that you already paused and played. So here we go. The initial amount is 10,000 again. The interest rate, I, is 7.5%, which is 0.075. This time we're going to let it ride for 50 years. Okay, so the interest rate is 1 plus I, or 1 plus 0.075. All right, and now N is 50 years. So here we go. Piece of 50, the future amount is going to be equal to 10,000 times our growth factor, 1.075, raised to the 50th power. And then, of course, we do it on the calculator. Much easier that way. Now, on the T, if you have a TI-84, you just enter it in exactly. Use the parentheses, 1.075, in the parentheses, raise it to the power, 50, and then you hit the go. You type it in directly as you see it. That's what's cool about the TI-84. However, most of you guys don't have the TI-84, so I would start with 1.05, raise it to the 50th power, hit the equal sign, and then times it by 10,000. And you get a lot of money. Look at that. So when you retire, you're going to have 371,000. Let's see, $897. And let's look at the pennies here. Woohoo, you get some pennies too. Come on. 46 pennies. Okay, that's when you retire, because it's after 50 years. You're 17 years old right now, or maybe 18. And 17 plus 50, that's 67. So this is when you retire. Ooh, yeah. How would you like to have that? You'd be a happy camper. All right. But most people will have more than that because you would keep on investing every year or every month. You throw more money in there, and the more money you throw in the bank, well, guess what? The more money you get when you retire, and you're going to need a lot of it. Trust me. Okay. All right. One more time. Try number 5. Pause the video if you like, and press play when you're ready. Okay. So let's check it out. So let me see. After 5 years. So after 5 years, you start off with 1,000. It's a 10%. So here R is equal to 1.1. 110% is 1.1, so 1.1 raised to the fifth power. Okay, so here we go. Let's try it. So 1,000 times 1.1 raised to the fifth power, $1,610.51. So there we go. All right, so not a whole lot, but it's better than what you started, right? It's over $600 more after 5 years. So better than nothing. All right, so now let's take a look at the second situation here. Instead of compounding it annually, okay, once a year, let's compound it monthly. Okay, let's highlight this. Okay, this is a different situation here. So this is what we do. This is how you handle it in a monthly compounding. In this example here, we started off with a $10,000 principal. Okay. Ooh, maybe I think I misspelled that. Oh well, who cares? All right, so P sub n, that's still your future amount. I think I must have been thinking about my wife here because she's the principal. All right. So, anyways, future amount here. P sub 0, 1,000 bucks. All right, that's it. That's your seed. That's your start. Okay, that's your principal, as I said there. Misspelled, I think. Uh, maybe it's correct. I don't know. So, anyways, you invested at 10% interest rate, but this time it's compounded monthly. That means 12 times a year. All right, 12 times per year. Per year, okay? All right, so not once a year, but 12 times a year. Okay, so we have to figure out what is the interest rate per month. If it's 10% per year, what is it per month? Okay, so this is 10%, all right, per year. All right, what we need to do is figure out what I call it P, the periodic interest rate per month. All right, I call this the periodic, all right, interest rate. Interest rate, all right, per month. What is that? All right. So what you have to do, since there's 12 months per year, you got to take your 10% here and divide it by 12. So you got to take 0.10 as a decimal, 0.10, divide that by 12. Now, if you want to write that down, go ahead. If you want to, if you want to do it on the calculator. So 0.1 divided by 12. Okay, that's repeating. Okay, so don't write it down. We're going to enter it in exactly as it is. So since it repeats, don't write the decimal down. Okay, the interest rate is going to be, in this case, 1, not 1 plus I, but 1 plus P in this case, because we're doing it compounding monthly here. All right, not annually. So it's not 1 plus 10% or 0.1 plus 0.1. It's going to be 1 plus 0.1 divided by 12. So it's 1 plus 0.1 divided by 12. Okay, now since we're compounding it monthly, and we're trying to figure out how much money will be in the account after 5 years, we got to figure out how many months there are in 5 years. All right, so n is the number of months in this case, because we're compounding it monthly. Monthly here, so number of months. I told you this changes. See, my definition of n here in the beginning was number of time periods. Could be years, months, days, whatever. So in this case, guys, what we have to understand is that n stands for the number of months. So in this case, if we want to figure out how much we have after 5 years, we got to take 5 times 12. Okay, and if you don't know what that is, take it on your calculator, just work it out. Okay, it's not that bad. 60 months. All right, there's 60 months in 5 years. Hopefully you believe me on that. Okay, so we got to find our future amount after 60 months. So that's piece of 60, guys, not piece of 5, because we're not, n is not in years anymore. Now we're in months because we're compounding monthly and not annually. Okay, so what we want to do is take $1,000 principal, which is our seed or initial amount. We want to multiply it by 1 plus 0.10 divided by 12 because we're compounding monthly here and there's 12 months per year. And you got to raise it to the number of time periods or number of months, which is 60. Okay, that's why these problems are definitely calculator based. Okay, so here's how you do it. I'm going to do it two different ways. I'm going to do it using the scientific calculator, do it the way you guys would do it, using one of these old simple little calculators, and then I'll do it if you have a TI-84. Okay, well, I'll tell you what, I'll do the TI-84 method first. So here we go. Here's the TI-40. You just type it in directly. Okay, use parentheses 1 plus 0.1 divided by 12. Okay, so you type it in directly as you see it, close it off, raise it to the 60th power. I mean, the TI-84 makes it super simple. All right, and you get 1645 and 31 cents. 1645 and I think it said 31 cents. 31 cents. Which, by the way, is better than before. See, compounding annually, like right up here, compare these. That's why I said uh, monthly compounding is better because it is. This is higher than the previous one here. We got the same problem done two different ways. And that's why I put these back to back because I wanted you guys to see that if you compound it more times per year, like monthly versus once a year, well, you get more money in the end. We have 35 more dollars almost, okay? Hey, and that's better than nothing, all right? So this one's better. But the question is, how do you do this on your little scientific? Because most of you guys have a little tiny scientific calculator there. So watch closely. I'm going to start here in the inside the parentheses. All right, so I would start off with your decimal, a fraction actually. So 0.1 divided by 12 plus 1 equals, hit the equal button. That's the inside, that's the base of the growth factor here. Raise it to the 60th power, raise it to the 60th, multiply it by 1,000, times by 1,000. Hopefully you were watching right there because look at that, I get the same number, okay? You guys can use even a basic calculator to get all this. You don't need anything fancy like mine. All right? You just have to have something, some kind of decent calculator. Okay, so here we go. Let's practice here. If you want to pause and play, go ahead and pause it and try it if you want, or just keep it running. So here we go. Let's get the future amount. Remember, piece of n is just the future amount, as I keep on saying throughout all these examples. All right, my seed or my starting principal is $5,000 in this example. The account pays 8%, so 8% as a decimal is 0.08. And again, it's compounded monthly. Same problem. Okay, so my periodic interest rate, I got to take 0.08 and divide it by 12 because there are 12 months per year. This is my periodic interest rate. Now my growth factor is 1 plus p, or 1 plus 0.08 divided by 12. Now I want to figure out how much is at the end of 4 years. And remember, this is in number of months now. Okay, because we're compounding monthly, not yearly. So we got to take 4 times 12. 4 times 12. Okay, that should be 48. Come on. Go. I see I'm faster than my computer here. It's 48 months. All right, so here we go. Let's find how much money we have after 48 months. We'll call that piece of 48. All right, we're going to invest 5,000 now. We're going to take 1 plus 0.08 divided by 12, raise it to the 40th power, and figure that out. Okay, so I'm going to clear it out. I'm going to do it the way most of you guys are going to be doing it here. I'm going to start off with my fraction, 0.08 divided by 12. Enter, or equals, plus 1, equals, raise it to the 40th power, equals, times 5,000, equals. And I get a bigger number because this is growing, right? 6,878. All right, how many cents? Come on, 33 cents. Look at that. Okay, so 33 cents right there. If you were going to use a, oh, come on. See, my computer's having issues right now. Sorry, guys. Oh, okay, there we go. If you want to type it in directly, if you have the TID4, type it in directly. Use parentheses. 1 plus 0.08. Oops, not 5, but 8. All right, divided by 12. Close out the parentheses. Raise it to the 48th power. You type it in directly as you see it. You get the same value. Look at that. So there you go, guys. All right, last example. Here we go. So let's suppose we start off with $10,000 this time. Oops, that's supposed to be the future amount. Sorry. P sub n always stands for future amount. P sub 0, the seed, there's P sub 0 is 10,000. This time we paid 12%, so 12% is a decimal, 0.12. Periodic interest rate is 0.12 divided by 12. 12% divided by 12 is 1%, so it's 0.01. All right, this is 1 plus P, or 1.01, which is 1.01. Okay, all right. And if you didn't believe me there, you could take 12, I mean 12%, which is 0.12. Look at this, divided by 12. If you don't believe me, you get, well, you got to type it in correctly, so let me try it again. My computer is not running well right now. It's too slow. Or I'm too fast, one of the two. See, I'm not putting the numbers in right. 0.12, there you go, divided by 12. There we go, 0.01. So there you go. Hopefully you believe me now. All right, and then how much will we have after 20 years? So again, this is number of months. So since there's 12 months in a year, you got to take 20 times 12. All right. Oh gosh, here we go again. So 20. Come on, 20 times 12. That should be 240. So 240 months. So here we go. A piece of 240 would be my seed, which is 10,000 times 1.01 raised to the 240th power. All right, so here we go. Now these look like complicated problems, but not with some decent technology like a simple calculator. So take 10,000, times it by 1.01, raise it to the 240th power. All right, and what do you get? Ooh, look at that, 108,925. All right, what is that? I mean, how many cents? Let's take a look at it here. Ooh, look at that, 54 cents. Not bad, okay? If you let $10,000 ride for 20 years, you'll have over 100 grand. Not bad, okay? You're 17 years old, so by the time you're 37, you'll have over 100,000 in the bank. Most people don't even have that much money, okay? All right, be smart. Put some money away, let it ride, and then when you start a family or buy a house, you'll have plenty of money to make a down payment. Okay, think about it. All right, so let me show you even a better situation here. Let's compound it daily, every day of the year, every 365 days out of the year. All right, this is even better. So let's take a look at it. Okay, on this one here, we got initial amount. Well, actually, P sub n is the future amount. Remember that? Okay, but we got an initial amount of $1,000. So let's say that we throw $1,000 in the bank and invest it at 10%. Okay, which is equal to 0.0, excuse me, 0.10, 0.10 there. And this time though, ooh, look at this, look at this. Ooh, okay, compounded daily. Now we know there's 365 days a year. Okay, so we're going to compound it 365 times. So not one time a year like an annual situation, not compounded monthly 12 times a year, but we're going to compound it 365 times per year. Okay, so here we go. If we done, and then what happens after 5 years? Okay, so we'll figure that out. So my periodic interest rate is 0.10 divided by 365. This is still 1 plus P, or 1 plus 0.10 divided by 365 Don't even bother doing that on the calculator because it's going to be a repeating decimal, so don't worry about it. How many days in 5 years? Well, let me see. This is number of days now. All right. Because of that, it's 5 times 365. Okay, so if you can't do that in your head, no big deal. Work it out. 3 times 365. Okay. Come on, guys. Use your calculators. Just don't sit there like a bunch of meatballs. Come on. All right. Use your calculator. Work it out. 1825. So 1825 days. We're going to compound it 1,825 times. So the amount of money that we have after 1,825 days is going to be equal to my original deposit, 1,000 bucks, times 1 plus 0.10 divided by 365, raise it to the 825 power. Ooh, I mean, look at that. That's awesome. Okay, gotta love mathematics because it can solve all kinds of cool problems here. Okay, let's work it out. Okay, so let's do it this way here. Let's do it the way you guys are going to do it on the calculator. The little guys, okay? I'm not talking about height. I'm talking about the little calculators. Okay, so 0.1 divided by 365. Hit the equal button. All right, add 1. Hit the equal button. All right, raise it to 1,825 days. Okay, and then times it by 1,000. Boom, that's how you get your answer, guys. Okay. Here we go. So we get 1648. Hopefully I did that right. I have to check my calculator there. And 61 cents. Let me check the calculator because I was going a little fast. So 0.1 divided by 365, add 1, take it to the power, and then time. Yeah, that looks good to me. All right. That's how you compound it daily, guys. Now in this situation, we start off with $5,000. We have an 8% interest rate, which is 0.08. We're going to compound it daily. Ooh, I can't spell. Look at that. I just figured that out. You guys, I'm not the greatest typist in the world. I'm a better mathematician, okay? If we don't touch the money, how much money do we have after 4 years? Okay, so here we go. Okay, so let me see. The periodic interest rate would be 0.08 divided by 365. This would be 1 plus this, 0.08 divided by 365. How many months in 4 years? So 4 times 365. Ooh. Got to put the sound effects in. Okay, so 4 times 365 gives you a number of days, 1460. All right, so let's find the amount after 1,460 days. So you start off with 5,000 bucks. You got to multiply by 1 plus the periodic interest rate, which is 0.08 divided by 365 because there's 365 days a year, and raise it to 1460 because there's 1,460 days in 4 years. Okay, and then you work it out. All right, so let's try it. So here we go. 0.08. 0.08 divided by 365 equals plus 1 equals raise it to the power equals times 5,000 equals 68.85 and 40 cents. All right. There you go. That's all there is to it. 2 more. Okay, remember, pause and play in the video here. If you think you got it, pause it and work it out ahead of time, okay? Be smart. All right, and try it ahead of me. All right, so let's suppose you got you start off with 10 grand, pays 12%, 0.112, 0.12. It's compounded daily. And how much do we have after 20 years? So the periodic interest rate is the 12% divided by 12, which is 0.01, because obviously if you take 12% divided by 12, you get 1%, and 1% is a decimal, is 0.01. And then this is going to be 1 plus 0.01, which is 1.01. And we have, let me see, 20 years. So 20 times 12, that's 240 months. Excuse me, I'm doing days, not months. Silly mistake, Ainsworth. Okay, hopefully you guys caught that. We're talking daily, okay, not monthly. So 20 times 365. Holy cow, what in the world is that? So, everybody say, holy cow! Okay, so 20 times 365. Getting a little crazy here because it's getting late and I'm getting tired. 7,300, how about that? So 7,300 months. It compounds, excuse me, not months, days. It compounds 7,300 times, guys. That's why this is a better than monthly and better than annually. So the amount that we have after 7,300 days is equal to the amount that you deposited initially times 1.01 raised to the 7,300 power. Look at that. All right. So this time I'm just going to type it in directly. So for those TID4 lovers, here we go. You just got to make sure you type in, whoops, 10,000. So I got to put in the right number of zeros. That's what you got to be careful, because good input, it gives you good output, but bad input gives you bad output, right? Okay. Ooh, look at that. Okay. This has got to be wrong. What did I do wrong? I did something wrong. Let's see. Okay, what did I do wrong here? So, oh, sorry guys, it's getting late. I have to divide this by 365, and then this right here. I knew my answer was not correct because it was too big. Okay, 1 plus 0.12 divided by 365. Sorry. It is almost 10 o'clock and I have a headache, and so I apologize. Please forgive me. So this is 1 plus 0.12 divided by 365 raised to the 7,300 power. Let's redo the calculation because this number is way too big. When you end up with an answer that doesn't make any sense, you know you made a mistake. So that's why, I went back and checked it, because the answer couldn't have been that. I know it's bigger than 10,000, but not that big, man. It's not a Fibonacci number here. We're not talking about F100. So let's type it in correctly. All right, let's do it correctly here. We got to divide it by 365 because we're talking about daily compounding here. And we're going to raise it to the 7,300 power. This should be better. Better. 110,188. 110,188. This is a comma. 188, and how many cents? 29 cents. That makes more sense. My previous answer was way too big, okay? And so when that happens, you guys, it's probably because you didn't set it up right or you didn't push it in right on your calculator. So always check your work. All right, look at the person next to you and say, always check your work. Okay? All right, pause and play. Pause and do this first. Do this last example here. Okay, go. All right, so last problem, 10,000 bucks. There's my seed, 12%. So 12% there, 0.12. All right, this time I'm going to do it right. So 0.12 divided by 365. Because there's 365 days a year, because we want to compound it daily. How much money are we going to have after 50 years? So I don't know. So 1 plus 0.12 divided by 365. Let me see, 50 years times 365 days. What is that? I don't know. Okay, so what's 50 times 365? It's big, right? 18,250. So 18,250 days. In 50 years, there's a lot of days, right? So here we go. This is a big one. So how much money do we have after this many days? So we start off with 10 grand. This is the retirement example again. You're about 17 or 18 years old. 50 years from now, you're probably going to retire. If you invest 10 grand at 12% and you compound it daily, this is what you're going to have when you retire if you don't add to it and if you don't touch it. So 1 plus 0.12 divided by 365 raised to the 18,250 power. Here we go. So 10,000, okay, times 1 plus 0.12 divided by 365. I didn't type it incorrectly. There you go. Raise it to the 18,250 power. That's not right either. It's getting late. Sorry. Let me start over here. Okay. Got to hit the right buttons. There we go. 18,250. Okay, that, my friends, is 4 million. Ooh. Look at that. 4,030,000. 311 and 75 cents. Ooh, yeah. Okay, there's when you retire. When you retire. Okay, you're going to be a happy camper here, guys. You need over $1 million to retire. So I encourage you guys to invest your money. Okay, so if you take $10,000 and invest it at 12% and compound it daily and let it rest and don't touch it for 50 years, you're going to have some money when you retire. All right, so retire well. All right, do a good job. All right, now it's your turn to do all your work. Okay, make sure you show all your steps and make sure you do a good work. All right, check my notes online. So check online. Okay, your solutions. Make yourself proud. And I'll see you in my next lesson. This is Mr. Ainsworth signing off. Bye bye now.